Good morning. We're all the way up to part 21 of the virtual coffee break series brought to you by revolutionsimulation.org. Today we're going to hear in a second from Wolfgang Gens of the Uber Cloud with a case study. Before I turn things over to Wolfgang, though, I just want to give you a real quick run-through of RevSim. By now, I hope you've taken time to visit the site. If not, I invite you to do so. In addition to this webinar series, you'll find just a lot of other information regarding democratizing simulation, not only democratizing HPC that we're focusing on here, but all the different disciplines of engineering and simulation. So quickly, again, it's revsim.org. While you're there, I invite you to sign up for our newsletter. It comes out quarterly, so we're not going to bombard you with information, but if you're looking for a little more timely information, you can always follow us on LinkedIn and, of course, visit the website at your convenience. Quickly, I invite you to join this group of stakeholders at revsim.org. You can take a look there and kind of see a real good mix of different industry representatives, users like yourself, and moderators, and so forth. So I invite you to take a look. And at that, I'm going to turn things over to Wolfgang, and we'll get right into the case study.
Yeah, thank you, Bob. And this is Wolfgang Gens from the Uber Cloud, as Bob already mentioned. And today we are looking at a case study from the end user at Lobo Engineering about virtual testing of a severe service control valve on the Amazon Web Services AWS cloud. So quickly, you already recognize it at this picture. Severe service control valves are very critical for the safe, reliable, and efficient operation of plants, power plants, chemical plants, etc. And they are used in the most difficult installations within such a process plant. These installations commonly include cavitating, erosive, corrosive, noisy, high pressure, high temperature, high pressure drop, or high velocity media. So they are really very critical, and they come with a specific set of requirements so that there is a guarantee for long-term performance. And good valve engineering practice requires a thorough understanding of the relationship between the internal physical configuration on the one hand and the performance rating on the other hand. The engineer can then optimize a control valve design for the intended services with this background. Next slide. Thank you. So you already see some results here. You see this is a CFD, computation fluid dynamic analysis, and the control valve model is, in this use case, is used to minimize the effects of a complex body cavity and trim design. The control valve restriction components, or trim, reduce the annular area as the cavity profile on the right moves to the left when you look at the upper right picture. And you see the red dots over there. This is highest velocity in the valve flow. The end user, and this is Mark Lobo from Lobo Engineering, used Autodesk CFD software, which includes a vast array of tools that the valve engineer can apply actively to optimize his or her product design. Intuitive controls, robust help features, and deep online support allow the engineer for rapid adoption as a tool in the designer's toolbox. Okay, next. Thank you. So the engineer set up like a nice table which shows the approach on the resource usage. You see single desktop machine as local computing, then you see cloud computing, single desktop machines, and then you see a mixture of single desktop, private HPC cluster, and multiple solver licenses. So the beauty, I would say, with Autodesk CFD is that it sits in the cloud, it sits on AWS, and you can use your own licenses, but also you can use like on-demand pay-per-use type of licenses. As you can see here, the user estimated the simulation time altogether for 200 simulations on his local machine, and that would have taken him 1 month. And in the cloud, with using 30 AWS instances in parallel, because I mean all these simulations are independent from each other, because you are setting up this whole testing parameters, and then you can reduce it when using 30 compute nodes in parallel to do 30 simulations at once, reduce it to 1 day. Okay, with that, we have a very detailed case study available. When, for example, you simply in Google, you type in Übercloud Compendium CFD. So you will have about 30 fluid dynamics case studies there, among others this one. And having said that, I would like to thank you for listening and remind you to join the Revolution in Simulation community. You see the registration link here. And I also want to point out the case studies from Alan Chalker at OCS here with this link. The same, our Übercloud case studies, I already mentioned that, but also you can subscribe to the newsletter. With that, on behalf of Bob and Alan, I would like to thank you very much. And this was Wolfgang from the Übercloud.